I am Jessica Singh, and I'd like to welcome you to our documentary to celebrate National Science Week. And we are so privileged to bring you this documentary, which is going to exhibit what science means to the University of Limpopo and our community. And this year, this documentary is being brought to you amidst very difficult circumstances, and in that we want to virtually portray to you what we as a university do to celebrate Science Week and also our involvement in Science Week activities. We're bringing you this documentary in partnership with the Department of Science and Innovation, and together with our internal partners at the university, the various departments that are contributing to this documentary. In our exhibition of the various centers, we're going to bring you our Materials Modeling Center, our Limpopo Agri-Food Technology Station, together with other divisions of the university. That is our DIMAMO division, which is our population health division. Here we do research on population health and we feed into the National Atlas. So in celebration of National Science Week 2021, from the 1st to the 7th of August, we are showing you at the University of Limpopo exactly what we are engaged in as a university, and we are so proud to work with our communities with the whole idea of uplifting science within the UL environment.
From now on, we are going to see the documentary unfolding as Professor Ngwepe explains the structure of the Materials Modeling Center as well as other activities thereof.
3 areas we work in are minerals and minerals processing, light and precious metals alloys, and the area of energy storage, which is on batteries. And the tools that we use are mainly the software and the PC clusters and the high-performance computing facilities that are based in Cape Town. And these are the products that we are looking at the end: students, publications, conference papers, and intellectual properties. Our server at UL, we have seen the server room. When it was launched, it was the 120th in the top 500 worldwide. What we are doing is to model across what they call length and time scales, quantum mechanical calculations, which handle 100 atoms or 200 atoms. And you have the semi-empirical approaches, which enable you to handle close to 10,000 atoms to 50,000 atoms. And then you have the classical models, which enable you to model 1 million atoms up to 10 million. Now they are sort of gunning towards 20 billion atoms. Now, when you do that, then you come very, very, very close to what you are able to see experimentally on the nanoscale, mesoscale, etc. Now, in the area of mineral processing, our main focus is in the Limpopo. We're working on what we call the Bushveld Complex, the North Limb of the Bushveld Complex, which is found in Kopane, and Mohalakwena, Ivan Platz mine, and the Waterberg. And there we are looking at the reefs because the chemistry of those minerals is not yet well understood, and therefore we have to design new reagents which will optimize the extraction in that area. And so the PhD students work in that area. And the main thing is to sort of use modeling plus experiments. In experiments, we work with UCT, who do some experiments there, but we also work with Beijing Espring, which is the main tech of China, who are highly specialized in designing reagents. So the combination of modeling and the design of these materials, we model first and suggest the new products, and they go and do the synthesis. And once the synthesis has been done, then UCT does some of the experiments. And then from there, then we do the rotation until we get what is ideally suited for the extraction. The metal alloy development, after you have extracted the minerals, like the precious metals, you don't want to export them as they are. You want to add value to them so that the country can export high value materials. And this is where the metal alloy development comes in. And here we work within the program of the DSI, which is the Titanium Competency Center, whose center is at the CSIR. And then we design the different types of material where they do the shape memory alloys, which can remember the shape of the materials if you bend them, turbine blinds, and catalysis, which are used in ordinary cars.
Hello, my name is Dr. KW Poshoko, and I'm with my colleague Dr. KM Hatwani. We are systems managers here at the Materials Modeling Center at the University of Limpopo. We are responsible for managing the high-performance computing housed at the Materials Modeling Center and supporting a group of researchers as well as postgraduate students who are doing computational material science. So here we are inside the data center already, and perhaps I can quickly indicate that a data center is a technical facility that is very critical to the day-to-day running activities of the university in as far as simulations are concerned, computational material science is concerned, and it uses a lot of IT equipments that may be common to our day-to-day interfaces. Typically, you will find an array of servers that are grouped. Each of them represents what may be seen as a small computer, but then the idea here is to put them all together such that they can help us with the number crunching. So they are use of those researchers and students make use of these systems to be able to predict material properties, to be able to help experiments, to be able to look at how minerals. In the center we look at various themes of research. One is mineral beneficiations, metal development, energy storage technology development. So we use artificial intelligence powered techniques through which users are able to do research and study those properties. So, but at the background, these are the systems that do the number crunching. They are equipped with fast network, they're equipped with very fast processors, and there's space for which the data is stored. And because the nature of this environment is that it has to run 365 days a year as well as 24/7, there's a need to have environment monitoring. As you will feel, it's a bit cold, so because there needs to be cooling. So a data center will need to be equipped with cooling units. It needs backup power. It needs environment monitoring, and then it needs all other systems that are important for optimizing so that they can work efficiently. So what we do here, we not only use them for material science, but we also have certain older servers that we use to train students, and we train them to participate in supercomputing challenges.
My name is Dr. Nukungwepe. By profession, I'm a metallurgical engineer. So I've also done some work in chemical engineering. But we mainly focus on material science, specifically in this project. So we are part of the Materials Modeling Center, but we specifically focus on the synthesis of battery-grade materials. These battery-grade materials we use for lithium-ion batteries, which are mainly used for electric vehicles, but also for power tools, laptops, and several other unique applications. So my responsibilities are really, research. Firstly, to develop research and development to develop these battery-grade materials at the laboratory scale to pilot scale. And secondly, I also manage several labs which are dedicated for that specific purpose. We also do some research, so we do supervision of students at postgraduate level, so honors, masters, doctoral students. But we also collaborate with postdoctoral students who do computational work locally at the university. We also have collaborations outside the university with other institutions such as NEXA, CSIR, Nelson Mandela University, and several other universities locally, but also internationally. In America and China, we also have international partners. So we are a DSI-funded project, the Department of Science and Innovation, and we are part of the pilot, the manganese pilot plant group, which develops materials based on locally available resources. Okay, so most of our work is centered around this 4-liter reactor system. So to operate a system like this, you'd really have to have a background in either chemical engineering or material science, that type of background. So it's a 4-liter system where we control several variables at the same time to produce a specific type of materials. And when I say specific, there are different type of chemistries of lithium-ion batteries we deal with. So to give you a practical example, there are cars which are commercially available, such as the BMW i3, BMW i8, which use a specific chemistry of these materials that are produced. So those ones would have what we call nickel, manganese, and cobalt compositions of varying degrees. That's the chemical composition of the battery. We are developing the next generation of that type of battery. That battery was invented in the United States, in Chicago, by a group we work with. But the next generation of materials are such that you require your cars to have what we call a high energy density and power density as well. So those two factors determine how far your car can go, but also how powerful your car is. So when you compare a battery car to a engine combustion vehicle, you want your car batteries to have similar or better performance than what's currently available. And the costs are gradually going down, meaning that the world is slowly transitioning towards electric, battery electric vehicles and PHEVs as well. And that's the driving force behind that is the global warming phenomenon, which is currently happening, where the world is consuming a lot of carbon-based materials, and there's a shift towards moving away from that to more sustainable solutions. Science and technology generally have to do with solving problems. So as a nation, as a continent, there are a lot of problems we are faced with. Currently, for instance, there's a coronavirus issue, which is a big problem. In that type of problem, you need scientists, you need medical doctors, medical health professionals to come up not only with the healthcare we need, but also to invent products and vaccines which are going to deal with the problem. So the reason we have vaccines today is because there were people who had the training, the experience, and the financial backing to set up industries which could specifically develop vaccines and solve human problems. So we have a lot of similar types of problems, like for instance the issue of water, electricity. Those are big problems which we have in Africa generally.
I'm currently pursuing my PhD research on metal alloys, and they are of great application in automotive parts, turbines, as well as water pipes. Now, in this unit, we have infrastructures that assist us in being able to run various types of calculations, software programs to serve us. And for large calculations, we also have access to Center for High Performance Computing that is based at CSIR offices in Cape Town. Well, my work mainly focuses on phase stability and surface interaction of iron aluminides alloys. And this work is supervised by Professor H.R. Chauke and Professor P. Ngwepe. Well, this work will bring about great contribution to industries that mainly focuses on corrosion resistance, whereby we optimize materials for better applications, whereby in order for us to achieve such cases, we're going to have to look at various types of properties in order for us to be able to determine as well as reduce the rate at which corrosion takes place on steel for coating purposes. Now, it was quite a very challenging journey to go through. However, it is not impossible. It just needs persistence and encouragement from family and loved ones and the people that are around you. This will be of great impact. Well, one of the biggest issues is to never let yourself down, knowing that this is not just about you, but it is about bringing change to the community as well, and knowing that you've brought impact to the community. Now, all I would say is pushing and working hard yields a result, and the world has no room for people who are not ready to take on something different. Science is a different field that has not been pursued by many young women. Now, if you can come out and say, I can do this, is not gender-based, you will say to yourself, okay, this is what I have brought into the world, and this is the change that I have brought to the science world, and not just as an individual. So with that, I say pursue and hard work, you will yield results.
My name is Biti Shibiri, currently doing a PhD study. And then my research project focuses on spinel Li amino nanoparticles for lithium-ion batteries as a possible solution for electronics and vehicles. This study is being done at the University of Limpopo Materials Modeling Center, and then is being supervised by Dr. R.S. Lidwaba and Professor P. Ingwepe. So basically, my journey from undergraduate, I started my undergraduate at 2012, where I registered for subjects in molecular and life sciences because I thought I wanted to be a doctor. That was just a dream to be a doctor, but what kind of a doctor, I was kind of like puzzled. So hence I went for molecular and life sciences. But then as the journey went on, then I realized, no, I love science, but not this kind of science. So let me see and do something different. Then physics was of interest. Hence, I went to the School of Physical and Minerals. That's when I did my geology and physics. So going on, I realized that my love for physics grew compared to geology, which took us to the field, and I was not a hands-on person to say that maybe going to the field every day. So I loved more the computational part of it. I enjoyed being in the lab. So physics offered me a platform where I can do research or experiments, but in this case, using computers. So that's where the love started. And then after that, I did my honors in computational physics. And then furthering that, I did my master's, which was then converted in 2019 to a PhD study. And then because I had already accumulated a lot of work, so my supervisors and I thought it would be better to take the work and carry on to PhD. So encouraging someone who is at home who wants to do physics or who wants to do any kind of science, I would say if I'm talking to somebody who's in high school or going to high school, I would say choose subjects in the STEM field, which are physics, science, mathematics, life sciences, yes.
For someone who's in high school looking for a challenging career, looking for something which will give them employment after they graduate, science and engineering offer a very strong answer to that, because the demand for skills is global. It's not just in South Africa. It's in Europe, Asia, the United States, and Northern America, South America, everywhere in the world. There's a need for scientists, for engineers, for people in IT and technology. So the type of careers we normally associate with the type of work we do are people who are in various types of engineering, so chemical, mechanical, Because there's not just manufacturing the material. There's also setting up plants and things like that. So you're looking at technicians, various types of labor, scientists, people who do the research part, developers, but also people who are entrepreneurial and business people who are going to sell products to the general public. But you also need people who are in government as well to fund a lot of the development work. The research part of it as well. So you need researchers from, let's say, universities, technical institutions. So it's a whole range of people who are going to benefit, because it's not just electric vehicles, which is something which is currently taking over in Asia and Northern America, Europe, but not necessarily in Africa. But it's also the whole issue of where are we going to get our energy supply and how are we going to store it. So that's a big problem throughout Africa, where you have a company like Eskom, which supplies not just South Africa, but also a lot of the neighboring states. How is the average person going to generate electricity and store it during the day and use it up at night? The only way you can do that is if you can store that electricity, and the use of batteries offers a solution to that problem.
We are going to proceed to capture what unfolds in the Dimamo Population Health Research Center.
Welcome to the Dimamo Population Health Research Center. This is the center which has been funded by the Department of Science and Technology in South Africa. The center supports postgraduate students, especially masters and doctoral students, in relation to conducting their research. We mainly collect data in relation to demographic surveillance in the community, looking at the growing and the challenges which are occurring within our rural communities. The main aim is to assist government in resolving challenges within the rural areas. Students from University of Limpopo across all faculties are able to use the data which has been collected by our field workers from our study site. The support is in relation to them getting a platform to collect data and also be able to get some assistance in relation to the resources which we have within the center. We are now in our call center agent room, wherein our call center agents, they do collect telephonic data from our households. We've got an approximately population of 100,000, which they are calling on a daily basis. The main data which we collect is the upgrade of the socio-demographics and also the socio-economic status. We also look at the births and the deaths which occur in our community. They also do the HIV test, which they do in the field, and they also do the BMI measurements.
Now we will proceed and capture the activities of our indigenous knowledge systems at the University of Limpopo.
My name is Winston Ngumalo. I'm an associate professor at the University of Limpopo. My line of research is on medicinal chemistry. So just a brief overview and a short definition of what medicinal chemistry is. Basically doing chemistry that has biological applications. So our focus is to do chemistry to develop drugs. So we have two ways of doing that. We have what you call the conventional way, which is using our knowledge of science to develop new drugs by either looking at current available drugs on the market which have side effects, and then we try to improve them. Obviously, we have heard about things of resistance, so we try to improve on that. But the second approach, which we're also doing here at the university, is to rely on nature. And by relying on nature, we make use of plants which have been used by our ancestors for generations, where we know that they work. And so what we do here is to go and test within those plants what is it that is really active. So we have done a number of projects working with various communities, traditional health practitioners from different areas. Just to mention a few, I've worked with Dr. Hlati, based in Malamulele. I've worked with Dinda Technologies. I've worked with Inet Health Solutions, where they are currently using medicinal plants to treat various diseases. So we partner with them through our community engagement, and we work on those plants and basically just validate that they do work, and obviously determine what are the biocomponents that are responsible for the observed activity. So the nice thing about working with IKS or plants is that plants are known to be less toxic compared to synthetic drugs, and also they are easily available, so one can easily find them in the garden. You can plant them in your own garden, you can find them in the mountains, so they are easy to access and are relatively cheap compared to drugs which sometimes have to be manufactured in America, manufactured in Europe, and then they have to be shipped, and then you have to go to your pharmacy. So by working with communities, we can use our indigenous knowledge to make healthcare very affordable and very, very accessible. So that's the research that we do at the university. We have a large group where we train a number of postgraduate students, honor students, how to do the research, how to do the validation, and we also work with a number of partners and collaborators within the university who do the biological testing for us, and we also work with other universities for things that we don't have. So for instance, we have collaborations with the University of Cape Town, University of Pretoria, who also assist us with things that we don't have. So we are a fully fledged institution, research unit that has trained to date. One PhD student has graduated, and over 10 master students have graduated under my supervision, working in this area of medicinal chemistry. So for everyone, especially the young kids who have passion on making drugs and trying to find solutions for our country, for our community, you are more than welcome to come and join us at the University of Limpopo. We do have good facilities. We have been fortunate to raise a number of receive grants, which enable us to build our laboratories, to get equipment, which then allow us to produce state-of-the-art research. So as part of the Science Week, the theme being making it possible through science, we just want to encourage the young ones and the public to also consider having science or using science to solve our problems. Just want to encourage the young people that let's do consider science as an option, as a career. You don't have to do chemistry like we do. You can also do biological studies where you do the actual testing of the effectivity of those plants. You can do pharmacy where you actually do the prescription of those plants that we've worked with. So there's quite a number of careers that are available, but obviously before you can become that professional chemist or professional biologist or professional pharmacist, you need to make sure that you do your subjects at high school: maths, English, physical sciences, natural sciences, life sciences. Those are the courses that are required.
We now move on to the highlights that cover the Limpopo Agro-Food Technology Station at the University of Limpopo.
The objectives of the station are to analyze and test food products, to help SMEs turn primary agricultural products into commodities that meet market standards, to improve SMEs' products, process and development, and also to research on indigenous primary agricultural products. The station also offers internships to postgraduates, mainly at the University of Limpopo, which is referred as scarce skills. And also the station receives students for in-service training from different universities in South Africa, which are sponsored by SASC and also DAF.
My name is Rita Mufukeng. I am from the University of Technology, studying biotechnology, measuring and microbiology. So I've been here for LATS for the last 3 months doing my in-service training. LATS has exposed me to a lot of stuff. Basically what we do a lot in the university, we only taught how to do things manually, but here we are exposed to certain machines, softwares, how to use them. And basically what we do on a normal basis, we test different kind of food samples. So basically we test to count different kinds of microorganisms found in food, and that has taught me, or actually amplified me, to actually start a research of my own that I can introduce like different kind of preservatives, or maybe try organic preservatives as compared to the organic ones, because of the benefits of the organic ones. So being here in LATS has actually opened up a new dimension of which I did not, or I've never been exposed to at school, because mostly it's like theory and applying what you've been taught. But here you test different kind of samples every day. So it's a new and exciting journey for me.
My name is Petolo Sibanda. I'm the senior technologist of the station. Today I'm explaining a bit of some of the products that we make on the station. We have mayonnaise today, and the reason for mayonnaise is for us to explain what is food emulsion. So food emulsion has been part of the food industry for the longest time. We have milk as an example of a food emulsion, which is an oil in water emulsion, whereas mayonnaise is a water in oil emulsion. So what we do with the emulsion is that we all know that water and oil, they don't mix. So behind the science, we're trying to mix the two phases so that they can be dispersed, one can be dispersed into another. So what we use is an egg yolk. So the egg yolk contains an ingredient called, or a component called, lecithin, where it has two components, the hydrophobic and hydrophilic. So it's able to bind to the oil and the water so that they can evenly distribute within one another. So we have the egg yolk as our emulsifier, we have vinegar, which is the main component of mayonnaise, and then we have oil. So we're going to try to mix the two with the addition of the oil and see if they really do mix together. So additional ingredients would be salt. We have other spices if you want to just add in to give it a taste, a better taste. So I'm adding a bit of salt. And then we are adding a bit of vinegar. So we're going to give it a quick stir. When you add the oil into the vinegar, you have to add it drop by drop so that you can break down those drops into smaller droplets so that they can be able to disperse within the vinegar. So if I can get an assistant from your side to add just droplets. This is oil. So as you can see, the oil and the vinegar has been combined together and it formed like a thick mayonnaise. So from this now, we have to do analysis. So the first analysis that we look into is sensory analysis. So we have to check the appearance, we have to check the color, we have to check the taste, the viscosity, if the mayo is thick enough, and with this we use a rheometer. We have an equipment in our lab that does the viscosity analysis. So it will check if the product will be able to be scooped out within the bottle or not. Will it be able to spread if it's a product that needs to be spread, and so forth. Then we look into other analysis such as the water holding capacity. Will the product be able to hold the water for a longer period of time, the oil holding capacity, the foam capacity, is it foaming enough or not? So those are some of the analysis that we do as food scientists.
My name is Maureen Mamawolo. I'm the food technologist here at Limpopo Agro-Food Technology Station. We've done a lot of trainings and assisted a lot of people from the community. Just to mention a few, we have trained projects like TM Foods. TM Foods, they have a factory in Polokwane. They are making beetroot products, different beetroot products with different flavors. So we assisted them with food safety trainings and also with testing and analysis. So we did microbial analysis testing for them, and we also did nutritional analysis. And another project that we also had an effect on their success is Haros. They came here with an innovation of making a sweet potato yogurt product. So they had an idea, but then they didn't know how to make it. So we assisted them with product development project. And after that, then we also did a microbial analysis and also food safety training and nutritional analysis. And now they are selling at different places in Polokwane and also in Gauteng. They are selling at one of the local supermarkets.
We now move on to Water Purification Laboratory, where we will see some very important innovative highlights of university research.
In this lab, with our research, we are focusing on the treatment of wastewater, and then we're trying to recover clean water there and valuable products. With the valuable products, we mean the pigments. So with this, we are trying to avoid wastes that are produced by this reverse osmosis and then our other techniques, such as forward osmosis during the treatment processes. So what we do is we use different alkalis such as sodium carbonate, magnesium oxide, and calcium carbonate to treat mine water so that we can recover these soluble products and drinking water. So in this lab we have reverse osmosis which can be used, which can be used to treat that mine water. And then we also have forward osmosis, which is an emerging technology that can be used because we're trying to use that forward osmosis to avoid, to minimize cost, because reverse osmosis it's very costly as compared to our forward osmosis.
There is potential for us to make a difference through science. There is potential for us to work with communities. There is potential for us to develop industries, to develop manufacturing facilities using our indigenous knowledge systems through partnerships and through science. So in a nutshell, that is what we do at the University of Limpopo.
Thank you for watching this documentary, which has highlighted our flagship programs regarding science, technology, and innovation at the University of Limpopo. Let's continue to make a difference through science as we continue to find solutions for Africa.